PMIPCC knowledge sharing series. This initiative had been started last year at the onset of the pandemic in order to keep in touch with our members and other fellow associates who'd want to remain in touch with the Hyderabad the project management community. And since then, we have had more than 12, almost every month, knowledge sharing sessions, varied topics, right from technology to strategy to sometimes on self-help, improvement, so on and so forth. And now, today, this is the hot topic in the market nowadays. We bring you project management for artificial intelligence, machine learning, and data science projects. This is something each of us as project managers whoever have been dealing with these kind of projects may have been looking forward to, and we have been doing a self-learning or whatever it is. So in this context, we would like to welcome Srikanth Varma Chekuri, co-founder of Applied AI Course and Applied Roots. He's an ex-senior scientist at Amazon and Yahoo Labs, also a guest faculty at IISc Bangalore, as well as with a lot of more than a dozen years of experience in AI and ML products. Mr. Srikanth Varma Chekuri, welcome, and the floor is yours.
First of all, thanks to both Suma and Praveen for organizing this. Am I audible and visible? Just checking.
Yes, yes. Yeah, very good.
I'll start sharing my screen, and we'll start from there. Okay, cool. Yeah, cool. So,
should we start the recording? I'm so sorry, Srikanth.
No, I see that the recording is on, if I'm not wrong.
Perfect. Thank you.
Cool. Yes. Yeah, that will be helpful for others who could not join today. Cool. Sure. So let's get started. Sorry. Hello, shall I get started? Folks, is everything all right? Just checking.
Yeah. Please get started.
Okay. So we'll get started then. So first and foremost, thanks to Suma and Praveen for organizing this and for inviting me. So let me start with quick disclaimers before we go in. So this session is all about project management in data science, machine learning, AI. And as Suma already introduced, I'm a co-founder of an edtech startup called Applied AI Course and Applied Roots. I've been doing this for about 3.5 years out of Hyderabad. Prior to this, I was a senior scientist and lead at Amazon, both in Silicon Valley, Seattle, and Bangalore. And I've co-founded other startups. Most of my career has been at as a core machine learning guy, as a machine learning scientist, or as a co-founder of startups. So before we go there, I just wanted to say a couple of things. Please understand that I'm not an expert in project management. I'm being very clear here. Some of the questions you may ask with domain-specific terminology, I may not understand, so I'll ask for more clarifications. Just wanted to make that very clear. I do not come from a project management or a program management background. My background is mostly a scientist background or people. And again, all the lessons that I'm going to discuss here, these are lessons that I have learned on the job, either doing startups or building products at large companies. A lot of products and projects that I've done today serve about hundreds of millions of customers. Most of the ads that you see on Amazon search, when you search on Amazon, you get ads. The core machine learning backend was built by my team across Seattle, Palo Alto, and Bangalore. So most of my learnings about project management come from like in the ring on the field job. And there are also lessons learned actually managing projects and people across various geographies. So this is, I'll piggyback on some of the literature, but most of it comes from my personal experiences. Please understand that this is only a narrow view of project management in AI machine learning. It is just one team or one person's viewpoint. It could differ from others, and I would like to discuss other things also in the chat at the end. And another aspect here is most of the project management or most of the management side of things or building products, most of what I've done, whether it's building products or teams, I have built from the ground up. So I've been in very rarely in situations where there is already a product and I had to improve that. Most of the stuff I've done have been from ground up. So my experiences could differ from others. So with all that, I'm very happy I actually read this. This is a very nice resource that Suma and Praveen shared with me 3 days back when we were having a quick chat. This is probably one of the best resources that I have personally read. I actually read this whole, I think, 60 odd page document. Very well written. This is called the Playbook for Project Management in Data Science, AI, etc. This is published by the Project Management Institute in collaboration with NASSCOM and a lot of companies. And this was published in November 2020. I only wish that I had this handy a decade earlier when I was doing some of this work myself and we didn't know how to do it. So this is, I mean, if anybody wants to read beyond this session, this is probably the best resource that I came across, apart from some case studies that I found at Harvard Business Review or Wharton School of Business, etc. Apart from those, I think these are, I mean, lot of the key topics here that I will discuss also. I think 70-80% of it is available in this playbook, to be honest with you, but it might be a slightly different projection of it with some personal experiences. So, okay, so let me go here. Okay, so I'm just closing my panel just to focus on the video here. Again, I'll take annotations. Please excuse my handwritten notes. Again, to be very upfront, I've been teaching machine learning AI for the last 3.5 years, and of course at our own startups, we also teach academic programs in collaboration with University of Hyderabad and Indian Institute of Science. So typical software development projects versus ML projects, right? Again, just a quick show of hands, if you don't mind. Can I just go back to the poll? I believe there is a poll here, right? Can we have a quick participation in the poll? Okay, I'll just stop sharing my screen quickly because I want to look at the poll. Can everybody who is participating just quickly, Praveen, can you please activate the poll?
Yeah, give me a minute. I'll activate it.
I just wanted to get a context of where everybody is coming from so that I can pace the discussion accordingly.
Okay. Yeah, give me a minute. That looks like there is some glitch in the WebEx.
Okay.
I'll do it. In the meantime, you just keep discussing.
Okay. I'll keep going ahead. Okay.
Yeah, please.
So sure, no problem. So we just wanted to get a sense of the background of folks participating. Again, I understand that some of you may be coming from IT program management or project management. Some of you also come from non-IT backgrounds. So since there are people who manage software development projects or similar stuff, the fundamental differences, again, this is not an exhaustive list, but this is certainly a very important list of differences between different software development projects and machine learning projects. First and foremost is the availability of key ingredients. So typically in a software development project, you have some software, you choose to write code in a specific language, or you have tools. Most of those are fairly easy to acquire. So in the case of most machine learning and data science projects, these ingredients are sometimes very, very hard, sometimes even impossible to acquire. So the fundamental difference between a typical software project or an IT project versus an ML project, again, when I say software development project, it could be a product-based company, services companies, doesn't matter. Again, when I say machine learning project, it could be at a product-based company or a services company. But the core idea is this: there is a huge problem with availability of ingredients. The key ingredients being data, the platforms, and equally importantly, the expertise. And these are big problems. I'll touch upon each of these in the remaining few minutes. Again, the way we are planning to conduct this session, at least from my vantage point, is I'll go through the key points in the next 60 to 70 minutes, and then we'll spend the rest of the time in Q&A. I'll be happy to participate in an active interactive session. So, and the second thing is, unlike software development, imagine if you're trying to build a piece of software, right? There is a lot of certainty attached to it. You know that, okay, this piece of software can be written, it is not impossible, it's quite doable, and things like that. On the other hand, for machine learning projects, there is a lot of science part involved. So when you conduct actual experiments, again, these are not like chemistry experiments or biology experiments. These are like computer science experiments or mathematical experiments. A lot of experiments fail. there is a huge failure rate of actual machine learning experiments that you conduct. And that has to be accounted for in your program management and project management. The third very important thing is about measuring impact. When you build a piece of software, you can easily measure the impact because the software or whatever tool you're building gets productionized and customers, clients actually see this. On the other hand, for your machine learning project to actually create impact, you have to measure and quantify it. And the typical way that's done is using something called as A/B tests, also sometimes referred to as control treatment tests. Again, those of you, because we are in the COVID times, imagine there is any COVID drug or medicine or vaccine that is created today. It goes through a rigorous scientific testing process called control treatment tests, also called as A/B tests. Again, the control treatment tests in medicine are same as A/B tests. They're called A/B tests in the context of computer science experiments or machine learning experiments. So there is a lot of that science component which makes life harder. Again, along with the availability of ingredients. Again, the difference between a machine learning project and let's say some science project, let's assume you're building a drug, you're designing a drug, let's say. Ingredients are readily available. The core chemical compounds are readily available for you, right? Imagine you're working at a pharma company as a pharma scientist, right? Or a drug researcher. The ingredients are readily available. So the machine learning project management also differs from other scientific project managements in the context that the ingredients may not always be readily available, or even if they're available, they might be only partially available. So again, the closest thing to machine learning project management in my own experience and in my own hiring journey is machine learning projects are most similar. If I have to pick something that already exists, they're most similar to scientific projects. Now, what do I mean by a scientific project? I mean, let's say you're designing a drug at a pharmaceutical company, typically done by chemists, microbiologists, a bunch of scientists, right? The process of designing a drug, typically, I mean, unless you're working in the COVID times, typically vaccines and drugs take about 10 years to go from their first initial research phase to actual, like to be able to buy it in a medical store or in a drug store, right? So this process is very long, again, because of multiple reasons. And one of the biggest similarities between machine learning projects and drug development is things fail. Because in a drug development also, you first try out a lot of experiments, only some experiments succeed, vast majority of them fail. And after you design a drug, you have to then conduct A/B tests or control treatment tests to make sure that the drug is safe, that the drug actually works and things like that. So the closest thing to machine learning projects is like designing a drug in pharma. Again, I've also been fortunate to hire a lot of scientists from various domains. I was managing a team out of Palo Alto, which is in the heart of Silicon Valley. And I was very fortunate to hire scientists from a lot of backgrounds. I was able to hire scientists from physics, astronomy, chemistry, all sorts of basic sciences fields. And I learned that machine learning project management is very similar to projects that scientists in physical sciences, not just in pharmaceutical companies, but also in physical sciences. I was working with an astronomy PhD student at some point, and he said, hey, this process is very similar to what we do when we have to look at actual data from some of the telescopes that we collect data from and do a lot of analysis. So it's very similar to detecting a black hole or some astronomical phenomenon. Similarly, I was also fortunate to work with a lot of PhDs and folks who come from the core engineering fields, right? Computational engineering fields. Like I worked with people who had PhDs in computational fluid dynamics, etc. So there they said, hey, this process looks very similar to designing an engine from scratch. And remember, even the world's top manufacturers of engines, like you take your Toyotas of the world, or you take any major company that manufactures their own engines. They don't make engines every now and then, because designing an engine and building it from scratch is a fairly complex scientific process with, of course, a lot of engineering involved in it. So every few years they have a new engine. This is like the same engine or the same model of engine could be used in multiple cars with different capacities, right? So machine learning project management is closer to scientific project management in the context of these three examples. Again, these are examples I learned by working with people who had that sort of expertise, and these are lessons learned on the field. And the key lessons from the scientific project management world are these. Like I also talked to a lot of people who actually came from core science backgrounds. We also hired them for various roles in my own teams across the world. One of the great ideas or one of the great things that they do, which we don't do so much, at least in the computer science world, is they document everything religiously. Like literally, I've talked to a few very senior scientists who work in scientific fields at places like Lawrence Livermore National Laboratory and things like that. My manager himself was a very senior scientist who came from large government-funded research labs. So it seems in their world, they document every day's work religiously because there is so much of intellectual property fight that can happen. For example, look at CRISPR, right? This is all about CRISPR is this project about gene editing. There is now a huge legal battle on who invented or who came up with this process first. And the courts are literally looking at their daily documents or their daily notes that they've written on what experiments they conducted. Again, in the case of machine learning, IP may not be as critical an issue as in pharma or other areas, but a great lesson I learned from the scientific project management community or scientists who managed large scale, like multi-million dollar projects, either at the government or at large universities, is document everything religiously. This was super duper useful. So we made in my own organization and team. So we said, hey, let's have an internal wiki where every scientist, everybody who is working on the science aspects will write a daily log. It's as simple as that. You have to make a daily log on all the experiments that you're conducting, preferably if possible with timestamps, and you need to have a weekly summary. And the weekly summary has to be much more detailed. Every experiment you're conducting has to be documented so that even after you, if somebody goes and reads it, it has to be there. This might be slightly different from a typical software engineering or IT background where they don't have to maintain the logs of each experiment or each code snippet they've written. Of course, they have their own coding standards, etc. But this was a great project management tool. Again, this helped me. Again, in my own teams, I was managing about 80 odd scientists and engineers. And what we realized was, okay, having these daily logs is a great way to know where things are headed, what is actually happening without having to bug somebody every day. Of course, we had daily scrums of some sort, but the daily logs and the weekly summaries was a great way to catch up to know where we are. The next things were the typical metrics that you have in software or IT development or in other areas also may not actually scale well for machine learning and data science. For example, a few metrics that we used in our own teams were the number of experiments that people were actually conducting and what is the incremental lift in the actual machine learning output itself across experiments. This is equally important because somebody could say, hey, I've done 100 experiments last month, but if all the 100 experiments are useless, what is the point in it? So the types of metrics that we have to use changes in the context of data science, machine learning or related problems where number of experiments does matter, but what is the incremental lift across experiments? That is also super duper important. And very importantly, unlike other areas of project management, again, I'm not saying this is not there everywhere, because machine learning is very experiments driven. We have to allocate time to the scientists to design experiments based on the earlier failures and earlier successes. This time has to be allocated if we want incremental lift across experiments. Right? These were some of the lessons that I personally learned and we incorporated to great success in our own organizations at both at Amazon and my own startup. And it's working out reasonably well for us. Again, I'm on constant touch with my team, which has grown significantly even after I moved out. And the same process still works phenomenally well. Now, just to give you a quick overview of the machine learning lifecycle, again, please understand that this is incomplete. I just wanted to walk you through the data science machine learning lifecycle to give you a context on what I'm talking about and how this lifecycle is not as simple as this. While I'm trying to draw it in a simpler form here, it's actually not as simple as this. But just to go into that lifecycle part, right? So you often sit on raw data. This is the data that your company has collected or acquired, whatever it is, just raw data sitting typically in a database or a data warehouse or just simple data logs, right? So this is your raw data. Now from the raw data, a bunch of your either whether they're data engineers, data scientists, whatever they are, they start pre-processing this data. So you have raw data. It could be stored across multiple data warehouses, databases, etc. The pre-processing stage is all about taking the data, doing the basic pre-processing to make sure that you have the data in the format that you can consume further. Okay, I'm just giving a simplified view first. Okay, then once all the data is in place, or at least most of the data that you want is in place, then you go into the data analysis stage. Again, data analysis typically involves using statistics, decent amount of math, and of course, some amount of classical machine learning techniques to just analyze and visualize and see. Again, there's a lot of data visualization that also happens during the data analysis stage to just understand what the heck is happening in the data. This is a very exploratory stage oftentimes. And then once you have the data analysis done, then you say, hey, these are the metrics. For example, just to give you an example of what a metric could be, right? So imagine you're building a recommender system for Amazon, right? Your metric could be, okay, my machine learning models that we want to build, we want them to generate, let's say, what could be a good metric? The lift in revenue, right? The business only, again, if you think about it from a retail business perspective, your metric could be, I don't care how fancy models you build. I just want that your system doesn't suck, doesn't create customer issues, and most importantly, from the recommendations that you provide, hopefully people buy more. Simple. Okay, that's a business guy's metric. So great. So when we talk with product managers or the business owners of it, cool, very good metric. But at the same time, you need to define internal metrics because you can't go and show the actual lift in revenue right away till the time you put your models into production, right? Till the time you don't do that, you have to somehow have mechanisms or internal metrics, right? So you have a business metric and you have a science metric. Oftentimes, the science metric might be harder for business people to interpret, and the actual business impact itself might be a little harder to actually show right away, because that might come maybe 3 months later or 6 months later, sometimes even after a year. So you need to define both metrics from a business standpoint and also, as usual, from the engineering standpoint or the science standpoint. Again, your scientists in the team would know that they both have to be highly correlated. Otherwise, it's all a useless exercise. So defining metrics, while it seems like an easy thing, it is not at all easy. I have spent months together just convincing all the stakeholders that these are the right metrics in various products that we have built. For example, let's take Amazon search ads, right? What do you think? I mean, there's a lot of complexity because the retail guys say, guys, you want to make money through ads, we're very happy. But if the customer experience gets spoiled even by a bit, I will not tolerate it. I'll shut down your ads tomorrow. Because my customer experience, because Amazon as a company has a lot of this customer obsession type of mindset, right? So they say, I don't care. But if you drop the customer experience or customer satisfaction with our search results, we will throw you out the next day. And that's a valid point from their vantage point. The ads team says, hey, we want to generate a few $1 billion through ads because so many hundreds of millions of customers come to our website. Why don't we make money? Again, this money will be used to improve the whole customer experience, reduce prices, all of that stuff, right? Again, the science guys will say, dude, we don't know when we are going to get shut down. How do I measure that customer experience is not sucking? Right? These are very important. So there is a lot of back and forth with a lot of stakeholders and business partners in this defining metrics. Then once you have data, you define metrics, you start going ahead and building actual machine learning or deep learning models. Now, once you build models, again, your first cut model may not actually work in practice, but you experiment. When I said experiments a while ago, I'm talking about this phase and this phase. You experiment a lot. Of course, in data analysis also, you do a lot of simple data analysis, which is experiment driven. Again, let's assume you do all the experiments and you're confident that, yes, I've built a machine learning model which can recommend better products or which can show good ads to customers. And then you say, cool, let's actually test it. Again, here testing could mean multiple things. It could mean simple software testing. I'm not talking about software testing here because I would assume that some of that is taken care of by the software engineering team. When I say tests, I mean, okay, what happens if I actually deploy this model? Will it actually work? How can I be sure that this model actually works in practice? So we do this control treatment type of stuff wherein we say, hey, for 50% of customers, let's not show the new recommendation models. For 50%, let's assume we show the new models. So let's assume somebody built some simple rule-based system to recommend products. And now you have a new machine learning team that is recommending new products, right? Now you have to measure what is the actual business impact, what is the actual lift in revenue because of the new models. Similarly, if you look at search ads, right? You have to now say, hey, by showing search ads, we are making this much incremental money without the customers leaving our platform, right?
Good morning.
Hey, may I request the people to be on mute?
Sure. No problem.
Thanks, Srikanth. Go ahead. Yeah.
Hey, no problem. So just to give you that context, so here tests basically mean the actual control treatment, A/B test, the rigorous scientific tests that you have to perform to actually prove that all of the effort you have put in the last 3 months, 6 months, or even a year actually create business impact, right? Once you show that business impact, you go back to your stakeholders and say, hey guys, we are able to create $100 million more. And after creating this $100 million impact, again, we are creating, so for example, for search ads at Amazon, right? We could say, hey, we are creating, by deploying this, we can create $100 million more revenue in the next 6 months or 1 year. And we observe that customers who are shown these ads do not think it sucks. How do I know that these ads don't suck? Because people are actually clicking and buying things from there. So they don't even think that these are intrusive or these are bad for them. A lot of customers think of these as actually information, right? So all these metrics actually, again, you have to do all these tests. And once everything is cool, then you work with your software engineering team, your DevOps teams, etc., to deploy the models and then monitor them. This is the linear way of looking at a data science machine learning lifecycle. But in reality, this never works out like this. Let me just show you a diagram. So this is a simple linear approach of thinking about it. In the real world, this is what it's going to be. Again, I've only done partial arrowing here. I've not drawn all the arrows. Let me give you some examples. I'll just explain some of these arrows here. Suppose you're performing data analysis. And while performing statistical data analysis, you realize that the pre-processed data that you want to use, it's useless. Or you don't have the data that you need. Sometimes the raw data itself could be useless. Let me give you an example. So imagine, again, data is literally the fuel for all data science problems. This is where I have a dedicated slide just on data itself in a couple of minutes. But just to give you a sense of it, right? Imagine if I'm trying to, I work at a company like Philips. I'm just giving a concrete example here. And we want to build a technique to scan X-ray images to predict if somebody, X-ray, not MRI, just X-ray images of chest, and diagnose whether somebody has COVID or not. Again, that will be extremely good because it's an extremely cheap way, quick way to diagnose. Again, I know some research labs across India which are working on similar problems, not just India, but also in the US and Silicon Valley. So now you say, hey, do we even have the data for it? Or do we have reasonable amount of data? Or do we have data that has been whose data quality is assured by actual scientists and doctors, right? So these are actual problems. For example, when you're doing data analysis, you might come up and say, hey, I just don't have all the data in the processed form, right? Or I just don't have the raw data anywhere else. Or it could so happen that my raw data is sitting in some data silo somewhere. Some other team is managing it. Probably my data is sitting in somebody's Excel file. I've been through those journeys where actually data, even in a large data-driven company like Amazon, I've been in cases where some data was sitting in somebody's Excel, not even in a database, because that's how they were operating for the last 20 years to detect fraud, right? So the data could just not be available readily for you. Similarly, let me give you more examples. While defining your own metrics, you might realize, hey guys, this metric is just not meaningful given the data analysis that I've done. So I have to go back and redo my data analysis. I have to go back and redo my data analysis to say, hey, can this metric even be measured thoroughly, scientifically, in a rigorous statistical fashion? Similarly, you might say, hey, suppose I'm building my model. While building the model, something breaks. Then you have to go back and start doing data analysis from scratch. Or you're doing some experimentation with models and things break all the time, right? You have to go back and start doing data analysis. or you're monitoring your models. You're saying, are my models running as I expect? They don't always. Then you have to go back to the drawing board. So there are a lot of these backtracking loops, as I call it. Again, backtracking is a computer science term. What it means is you're just going back on what you have done earlier to redo it so as to be more sensible in the whole process. So in a data science life cycle, while the data science life cycle might look linear at the outset, there is tons and tons and tons of backtracking. And as a program manager or a project manager, it is also your job to keep track of where is what. Otherwise, it'll imagine you're managing a team of even 10 scientists or scientists and a bunch of engineers. Just this backtracking will kill you because it's so hard to keep track of things and where what is, because everything breaks. Unlike a typical software development where the life cycle is much more clean, whatever methodology you're using, right? You build some code, you test the code, you know it works. In the case of machine learning, no. Even though you do all your analysis, everything could fail at the last minute. And it actually does, right? So let me give you a simple idea. So let's assume you're building the very first cut solution. Let's call it V1. Okay, this is your first cut solution that nothing exists right now. Okay, you're first taking up this problem. This is the first iteration of this problem solving. Oftentimes, just going from raw data to pre-processed data will take 60% of your time. Lot of people don't focus on this. Lot of data scientists, machine learning scientists, they fancy data analysis, they fancy machine learning models, all of that stuff, because that's where their core skill set is. That's where they can leverage all the complex math that they've learned and become good at. But in reality, when you're first building the V1 of any product or any piece of data science, whether it's a product or a service, more than approximately 60% goes in just going from raw data to pre-processed data. And the reason why this happens is data doesn't exist, or data exists in all sorts of crazy places. Just getting your hands, understanding the data, because your raw data some data could be in some database one, the other data could be in some data warehouse, some other data could be there in just some log files on some servers. It could be all around the place. Sometimes it's also even in Excel sheets of somebody's laptop or desktop, right? So you have to gather all this data and understand what each field means. Imagine doing it at a scale of a large company, right? The amount of data that you have to just understand. Again, if you want to join these two, if you want to combine tables that are there in these two, right? Like your pivot table in Excel or join in SQL, right? You have to understand the heck out of it. This takes far more time than anything else when you're building the first cut version of your machine learning solution. And program managers need to understand this, digest this, and direct the team towards this. Because I'm telling you, your machine learning guys will push back and say, guys, this is not my job. Okay, I've been in the shoes of both a scientist who said this is not my job when I was younger, to a manager or a lead who said, guys, I don't care. If you don't do this, then nothing else exists. So sit down and do it, right? So other thing, very importantly, in V1, data analysis might happen very quickly, assuming that, again, today it's happening much more quickly than just 5 years back because of beautiful tools. Like, for example, you have tools like Spark right now. Those of you who know a little bit of distributed systems, like you can even take tens of terabytes of data and crunch it and do data analysis very, very quickly today. Earlier, it was much more challenging when tools did not exist. Like in my own teams, we built these tools from scratch when tools did not exist. Right now, life is becoming simpler for sure. The next thing here is a lot of time will go in defining the metrics. This is where program managers also play a very important role. They are the bridge business. They're the bridge between the business folks and the science and the engineering components. So defining metrics often is extremely important because it requires it requires you to convince all stakeholders, and it's never too easy, given that there could be conflicting interests at times, right? Some team might want your project to fail. That happens all the time in the real world, right? Because they think if your project is successful, they would lose out on something. So you have to get that stakeholder buy-in to define metrics. Building models, experiments, all of that is easy. Doing the tests at the very outset in version 1 of your problem, just doing the scientifically rigorous control treatment tests, also called as A/B tests, will take a lot of time. So if you look at it, roughly speaking, 60, 20 is 80, 90, almost 90% of all the time went into just pre-processing data, defining metrics, and doing tests. Only 5 to 10% of time you will be left with actually doing data analysis and building models. And since you're building the V1, you can just build very simple models and be done with it, because you want to first show impact as compared to having nothing, which is the status quo, right? So also, as a program manager, how much time you allocate to each stage depends on how mature your product or solution is. In V1, this is roughly what I have seen across tens of projects or tens of products that we have built or managed ourselves. Again, both at Amazon and also at our own startup. Cool. So let's assume what happens in V2, right? You built V1, V1 went through, cool, everybody's happy. Now you want to improve it. Here, again, roughly 30% of your time will go in raw data and pre-processing, because the best way to improve your machine learning models will be to obtain new sources of data. Again, at the end of the day, data is the gold. You might have the most brilliant machine learning people in the world. If you don't have data, they're sitting ducks. That's the reality of it. So you will spend roughly 30% of your time gathering more data, sitting with manual experts, human experts to gather more data, better data, higher quality data, etc. That is going to be very, very important. Next, a lot of time will still go in experiments. So you've built V1. Now, how do you get to V2? That's not easy. There is no simple path to it, right? So once you built V1 version, to go to V2 version, you will end up doing hundreds of experiments. The typical success rate is less than 10% in machine learning experiments. Typical, I'm talking about typical. I've seen teams, literally armies of machine learning people just doing experiments to improve, let's say, a recommender system model at Amazon, or a search results, to optimize the search results at Google, because those are like hundreds of billions of dollars worth of businesses. Of course, your testing also will take time, because let's assume you're conducting a lot of experiments, and let's assume you have 10 potential changes to your base model or to your baseline model that you can do. You have to conduct all these experiments, analyze this. So a lot of time will now go into, again, the experimentation could also involve building different types of models or doing more advanced data analysis, right? So all that will also be there. So as a program manager or a project manager, the amount of time you allocate would depend on whether you're doing the first cut model or you're doing a more advanced model. Now comes the most interesting challenges as somebody who's managing data science problems. The biggest challenge often is data challenges. This is the reason why people say, hey, 80 to 90%. This is probably the major reason, I should say. This is the major reason why people say 80 to 90% of projects fail in data science, because of data challenges. What are data challenges? Just simply acquiring data acquisition from multiple sources is a huge problem. That's because your data is sitting in different data silos. Of course, there are techniques like data lakes and other things, right? Data warehouses, etc., which are partially solving this, but still getting everybody onto a single platform is never easy. Then understanding, this is where a lot of your data science, machine learning, even program managers team, because a program manager has to understand what does this data mean, what can be done, what can't be done, right? So this is a huge challenge, and you need to allocate time for it, resources for it. We recommend a lot of program managers to sit on this, to sit in these discussions and actually understand this challenge, because they are the bridge between not just the business and the data science teams. They're also bridge between data science teams and other teams. They're also a huge bridge from other teams which actually generate this data, or which actually store this data or process this data already. Next major issue of data challenges is quality, and oftentimes just lack of data. If you don't have data, what do you do? Now, I'll give you a simple example. The X-ray scans example, right? Suppose you're trying to detect from X-ray scans whether somebody has COVID or not. Suppose if you just have, let's say, some 100 samples of COVID positive X-rays, and let's say some 200 samples of COVID negative. This may not be sufficient to actually build a cutting edge state of the art deep learning computer vision model. Oftentimes it's not. So your job as a program manager is to say, okay, there is no data. Where do I get data? How do I collaborate with human experts? How do I collaborate with human experts, collect the data, get the data through human experts, get the data labeled correctly? So this is also a very important part of data science lifecycle when you don't have data. Again, it depends on the vertical that you're working on. Again, teams need a lot more collaboration in the data science world because of data challenges and data acquisition, understanding quality, all of that. This is where I've seen some of the best PMs that I've worked with. This is where they play the most important role. Again, they have, like, I've had some phenomenal program managers, most of whom have actually learned machine learning on the job. And they have been phenomenal because they understand, by sitting in our discussions, by sitting in actual machine learning reviews and discussions, they actually understood how challenging these are. And the best PMs that I have worked with in my own organizations are the ones who smooth these things by working and collaborating with other teams. I mean, that's like godsend. If I can hire one such PM, life changes completely for any data science manager or leader. Now, the other problems that we see in terms of the process itself, in terms of the management, in terms of the life cycle of a problem is there is a ton of backtracking. This is again, this is something that happens very, very little in typical IT. I'm not saying it doesn't happen, but it happens all the time. It happens all the time in machine learning problems. And now, because of all this backtracking, how do you keep track of who is where? Who is where in this whole life cycle? How do you keep track of it? So we have started drawing some diagrams, and we tell our scientists and machine learning engineers saying, hey, every week in your weekly summary, please draw this diagram and tell us where you are. These are like simple visual representations that we have come up with. Again, this is not any framework or anything. These are hacks that we came up with ourselves. I'll show you a diagram quickly. The next thing here is each step takes very different amount of time in each version, right? Remember, the amount of time, like for example, take one step, which is like data acquisition. This takes different time in V1 as compared to V2. And this is again another place where I've worked with phenomenal PMs who understand those nitty-gritty details and who account for it, right? So you can't say, hey, here is a data acquisition thing, it will take 2 days. No, it will not take 2 days. It's impossible to do it in 2 days, right? Because you have to work with 10 other teams, understand the data, acquire the data. There'll be some exotic API that you have to call. Everything breaks down, right? So again, each step will take different time in each version. Again, the best PMs that I've worked with recognize this very quickly as soon as we do a couple of iterations, and they pace the project accordingly. For example, let's take a simple, again, this is a great place where I've had phenomenal PMs. Now, if you look at diagrams, right? So this is a simple diagram, right? Very simple. So we have this linear flow. Again, this is a shortened flow. There might be more stages than this. For example, from raw data, I've just written pre-processed data. It could be data understanding. It could be understanding each of the variables that I have in the data. It could be much more complex than this. So imagine let's assume Varma, who is a machine learning scientist. Okay, he has finished this stage, he has finished this stage, he has finished this stage, he has finished this stage. And he's in the 6th iteration of trying to build models, and things are failing. So in the 6th iteration, so he's in the 6th iteration of, again, because there can be a lot of these backtracks, right? So he went through this phase. So we know that this phase is over, this phase is over, this phase is over. And now here is where we are stuck. And we are now stuck in this loop. And we're doing this loop the 6th time, right? Again, because it happens. Less than 10% of experiments and models that you build actually work, right? So you do a lot of that experimentation, and we actually used to number experiments, right? Again, we used to have a Scrum process, the standard program management process for our software engineering teams. The same process may not work exactly as is for scientific projects or machine learning projects, but we had some diagram like this to get a sense of, okay, again, these diagrams have been improved over time and things like that. Okay, this basically says, okay, these are the stages that are completed. In this stage, this guy is stuck here. He's doing a lot of experiments. And if I see this number going too high, I would set up a senior mentor and say, guys, please sit down and debug. Something is going wrong here, right? So this is one simple way of doing diagrams to know who is where. So again, other challenges also exist. other opportunities also exist. Suppose you look at this process of building actual models, actual machine learning models. So let's say you already have some model. Let's call it the current best model. Like, so you've built your V1 is complete, the best model is pushed, everybody is happy. But of course, you have already hired an army of data scientists and you've set up a whole machine learning team. You want to keep building a better model. So in the modeling, one process that I've seen work very well, there are problems in each of these. One approach I've seen, there are two broad approaches. One approach is, hey, here is my best model right now. Everybody in the team try to beat this model or try to build a better model with this, right? So imagine if you have some 5 scientists or 5 engineers, machine learning engineers or data scientists, their job will be, hey, here is the best model. Let me go ahead and beat this. So it becomes more like an internal hackathon or an internal competition. The advantage in this is everybody has an objective to beat. The current best model is what they have to beat. So there is a lot of that competitive spirit that kicks in. That is good, but there is also a huge con in this. The biggest con I have seen experienced as a people manager in this process was, let's assume this guy's model wins, right? Others will feel left out. Others will feel that, hey guys, I have also put in like 3 months of effort to beat this model. All of that has gone down the drain. So in a winner take all type of competitive environment, there could be some of that team cohesion. Again, this guy will stop sharing all of his insights with others because he says, hey, if I share, probably he'll just copy my insight. That whole internal politics and internal bickering will kick in. So while we started off with this sort of model, we stopped it very quickly because we started seeing that the health of the team, the collaboration amongst the team, again, in science, collaboration is the key. While we celebrate great scientists, it is collaboration that is key in the real world, right? So while we tried this approach, again, in the PMI doc, this approach is talked about. I think this is called some challenger model or something like that, but a slightly different variation that works much better, especially for the team cohesion and for the buy-in from everybody is, hey, here is the best model. Okay, so your model is fixed now. So your model is fixed, right? This is my best model. You say, hey, machine learning scientist 1. So suppose there is one machine learning guy, there is another machine learning guy here, and there is a data scientist 2. We say, hey, tell me, can you come up with new variables? At the end of the day, the model is a function of variables that you feed into the model, and the variables themselves are a function of data. So we try to get in a buy-in. So variables are also called as features in machine learning. Right? So we simply say, hey, here is my model. I'm going to fix my model, right? Or I'm going to not change my model extensively. Can you change the variables or the features that are fed into the model by digging through the data better? Right? So here what happens is not just machine learning folks, but also your regular software engineers also will want to improve the model. They have a buy-in. They say, hey, I know the data better than everybody else. Can I do something better with the data? So it could be a software engineer who is sitting here who is saying, hey, I can also improve my model. And the advantage in this, the biggest advantage in this is all of them will collaborate because all of them feel that they have a stake in improving the model. Right? So it's a much better exercise, but there's a small con to this. Now let's assume this year your model generated some $100 million of business impact. Next year it generated some $150 million of business impact. Whom do you credit the $50 million impact to? Again, the reason in my own experiences, the reason I could go to my managers or the business folks or the business managers and say, hey guys, I deserve a 100% pay hike because I created $50 million of extra business impact, right? Don't you think getting a few $100,000 as a bonus or as an increment is a reasonable thing for creating huge value like this? Like I can actually show dollar amount and say, hey, this is our team's business impact, right? Now the problem here is how do you break it across? How do you break this business impact across everyone? Again, there are ways to do it. I'm not saying there are no ways, but they're not straightforward. So there are actually statistical rigorous machine learning techniques saying, hey, whatever this machine learning guy's work, how much did it contribute to the actual business impact? Again, there are techniques in game theory that my team has employed earlier. These are called Shapley values and things like that. Again, these are rigorous mathematical techniques that we as scientists knew all about. So we said, okay, of all the business impact, here is my strategy to say, hey, this is the incremental impact because of everybody. And this was a fair process because a lot of team members knew advanced mathematics, and we said, hey, this is a Nobel Prize winning work, right, in econometrics. You can go read up everything about it. It has mathematical guarantees. We're just using that to give credit to everyone, right? Of course, it's not always as simple as that, but sometimes you can do it, and you can do it reasonably. So the model that has worked well, I've also seen other teams, is instead of making it like a competition with a potential of internal bickering, as a program manager, you can organize your project somewhat on this, especially on the modeling front. Because you will be spending close to 50%. If you recall, I've shown this slide, right? Once your V1 is done, in your V2, almost 50% of your time, of your science team members' time, will be spent on experimenting and improving the models. You can do it much more collaboratively. Instead of using a competitive type of environment, more of a collaborative environment. Now, the other major challenge that used to be there earlier, that's thankfully going away step by step and slowly, hopefully this will not be a major issue in a few years from now, is how do you deploy all of the machine learning stuff that you've built? Because imagine if I'm trying to show ads on Amazon search, I have to work with the engineering team that is responsible for showing search results. So I have to integrate. So there is a lot of actual integration work with other systems that already exist, because machine learning is never the final product. It is a key component of a larger piece of software or a larger product. So the typical process in engineering is you have DevOps folks, you have engineering folks, software engineering, testing, all of that. So the machine learning team, especially the PMs, have to work in collaboration with DevOps and engineering folks to actually do this. Thankfully, now there is a whole field that's evolving called as MLOps. There are also MLOps engineers who are basically people who know machine learning, who also know some aspects of engineering and a lot of details about DevOps. And these are the people that PMs can collaborate with so as to make the integration process. Because however beautiful models you build, if you don't deploy them and integrate them into the typical workflow of the customers or clients, it's useless. It's as simple as that, right? So thankfully, this is getting solved because there's a whole new role called MLOps. But again, PMs play a very, very important role here also. Next. This is also super critical, especially in the V1. If you're building, again, I'm assuming that a lot of you will build machine learning or data science driven projects and problems in the near future. There will be a lot of problems in V1. When you're building V1, your whole control treatment or A/B testing platform may not even exist, right? This whole system itself may not exist, right? If it doesn't exist, building the engineering infrastructure is a major roadblock here. How do you build the whole system that does A/B testing? Again, this is a problem that my team struggled a lot with, and we literally said, hey, this is becoming the roadblock to do anything sensible, anything at scale, doing some 100 experiments a day and things like that. So my team, we said, okay, for whole of Amazon advertising org, let's build an A/B testing platform from scratch. So we took about, I think 9 months. We took away some of the engineers and statisticians from our team and said, hey, let's go build it. Once we build it, the problem is over, because now we can now conduct like tens of experiments or even hundreds of experiments simultaneously and see what actually works. So A/B testing infrastructure, especially in V1, if it doesn't exist, you have to plan for this, because without this, you cannot show any business impact. And a lot of times for building the A/B testing infrastructure, again, I've seen some teams which buy external tools, but again, that will be limiting, because if you're buying an external tool, integrating into your current system is not easy. And this requires building an A/B testing system from scratch, requires a lot of engineering effort, dollars of like we had literally a team of like 7-8 really good engineers taken away from the rest of the work and do this. So it requires a lot of buy-in from all the stakeholders, because your engineering infrastructure will also be used by others to actually do A/B tests. Because the ground truth that you've actually created impact in data science machine learning comes from A/B testing or control treatment experiments. That's the ground truth. Everything else is useless. If you don't show actual business impact through A/B testing, it doesn't matter, right? So that's a fundamental key takeaway. Again, another problem that a lot of program managers, again, I see a lot of program managers also becoming managers, senior managers, who manage a whole org or a team, right? So in those situations, skills are another big problem that I see myself. Again, this happens even at large companies or at a smaller startup. You need people with a varied set of skills. You need, let me give you a brief overview of what I mean by this. Again, these definitions might change from company to company. A typical machine learning scientist is somebody. Sorry. So a typical machine learning scientist is somebody who knows the state of the art, who can take a cutting edge research paper and actually implement it to improve your systems. Like these are typically PhDs, or these are typically people who have actually built machine learning products. Then you have data scientists. Data scientists know standard techniques. They know reasonably well. The difference between machine learning scientist and data scientist might just be that a machine learning scientist is at the bleeding edge of what is possible, while a data scientist knows the standard techniques. Then you have a role called as machine learning engineers. So your machine learning engineers typically are people who know some data science, who also know software engineering. So they can be a very good bridge between, so machine learning engineers can be a great bridge between your science team. So this is like your science team and your engineering team. Again, a lot of machine learning engineers are actually software engineers who have learned machine learning. Then you have data analysts who do all of the rigorous statistical analysis. So this whole org has to talk with the engineering people. And the nice bridge is the machine learning people, and a better bridge are the program managers. Program managers have to work as a bridge between the science and the engineering team. Again, the program managers also have to play a role between the science and the DevOps. Right? So program managers are a bridge here. They're also a bridge to DevOps. They're often bridge to data teams, whether they're database admins, data warehouse admins, data engineers. They're also a very important bridge, right? Of course, there's a big component here, which is the business folks, right? The people who care about actual business impact, your VP of product, or your director of product and things like that, right? So the PMs also are a huge bridge to the business guys. So the best PMs that I have encountered, again, I'm not saying these are the only people. I'll come to that in a while. Okay, so let's talk about costs. This is another thing where a lot of data science may be slightly different from other organizations, because a lot of program managers also do costing stuff, right? So hardware or infrastructure can be a huge cost. Like in my teams, I've seen, again, these are not, I'm not just talking about teams in India. I'm talking about teams like people with $500,000 comp, data scientists and people like that, right? Even with a top tier data science machine learning team, it's very common to see people spending more than 60% of their budget on the hardware and infrastructure. $10 million on hardware is not unheard of for many teams, right? Because look at this, if you're sitting on, let's say, a petabyte of data, especially at internet companies, right? If you're sitting on a petabyte of data, just processing this data, the amount of cloud compute resources that you need or on-premise compute resources you need is massive, massive stuff, right? Again, this is not true in all cases, but if you're working at an internet type of company or a company where data is typically in hundreds of terabytes or petabytes, you have to account for costs. The second major cost is the manpower cost, because everybody wants the good data science machine learning guys, right? Hiring is a huge problem. And I've been through journeys where we just have to, okay, I cannot go too deep into the numbers, but again, I've been in one of the hardest hiring places for data science and machine learning folks, which is Silicon Valley. And while setting up a team there, hiring good manpower is so damn hard, because there are 20 other FANG-like companies or unicorns sitting right next door. And that manpower can become very, very costly very quickly. Right? So that's another problem. Again, depends on the team, depends on the location and things like that. This may not be a huge problem in some companies, some organizations, or some locales, but in some places, this can become a huge problem. Again, this is from my limited experience. Again, in my own limited experience, I'm being very clear here that my experience here is limited. The most successful PMs that I have worked with, again, I'm not saying only these people will be successful in machine learning, but these are the types of people that I've seen really do phenomenally well. These are classical PMs. They could come from anywhere. I've seen PMs come from retail arms of Amazon, PMs who came from supply chain, PMs who came from IT, software development side, if they have a bent towards learning the components of machine learning, they don't have to become machine learning experts, but they need to have that drive to learn machine learning. So a lot of early PMs, I've done hundreds of interviews to hire PMs, and I have failed at many of them. Not because the candidate is not good, because my perspective was wrong, right? So we said all the PMs who join our team will sit in all machine learning discussions for the first 6 months. Every machine learning, so they're not given any task. They sit in machine learning discussions. They're actually mentored by a senior scientist or a principal scientist. They would work with them and learn the basics. I'm not asking you to become an expert, but if you have the appetite to learn this, in the long run, you're a phenomenal PM for the whole organization. That's one place. Okay. Second type of PMs that I've been fortunate to hire are people who come from scientific research backgrounds, like large national laboratories or large research labs at universities like Berkeley or Stanford or MIT and places like that. These are people who are actually scientists, but also managed large projects. That's a great skill set to have, but they're very, very, very rare, unfortunately, because there are very few people who fall in this category. The third type of people that I've seen are program managers who are very strong analytically. The strong math skills, actually, when somebody has strong math background or strong, strong math sense or analytical sense, they can pick up machine learning in no time at an intuitive level, I'm not talking at a deep mathematical level, but once somebody can think from that aptitude mindset, they can quickly pick up the foundations of machine learning in no time. Again, they don't have to be experts, please understand that, and they can excel phenomenally well. Again, this is a small subset of people that I have worked with. I'm sure there are many, many other people who have become very, very successful. This is only my limited experience and exposure. So I think that's all I had for today's session. Again, I know that I have used some terms without defining them. I've tried to define them vaguely, like A/B tests, etc. So feel free, anything that you've not understood, please ask me. I'll be happy to answer, and the floor is open. Again, you can put your questions either in the chat window or Q&A. Maybe Q&A is better. Okay, or Q&A, already people have put in your questions. So I'll try to take the questions in the first come, first serve order. Okay, cool. Okay, so I'm just scrolling up. There are many of them. So after all the good mornings.
So Srikanth, first question.
Please, yes.
With such a high failure rate, how does the project or a program management keep the team motivated?
Cool. Very nice question, actually. So at least in my own team, I used to tell people when they join, especially from graduate schools or from their PhD programs. Again, if somebody is coming from a PhD program, that's okay, because they know that in PhD, everything fails. But if people are not coming from a scientific PhD research type of background, I tell them that, especially youngsters, I tell them that this is the status quo. This happens all the time. And people realize this in the first 2 months, because at least in my team, we used to have these science dive deeps every week, wherein everybody, it's an open forum. It's a mandatory for all science folks. And also we requested a lot of engineering folks and all PMs to join this mandatorily, which is you have to come in and you have to now sit and listen to the key summary. If you don't want to go into the math, that's okay. You have to sit in the team discussion. What happens in that is people realize that even for the best of scientists in their org, 80-90% experiments fail. And they realize that that's the status quo. And it also depends on the performance structure that you define, right? So this happens especially for software engineers who come into machine learning. They think that, hey, my experiments are failing. What happens to my annual review? You have to make it very clear that these are the key metrics that we will measure in your annual review. So in my team, we used to say number of experiments, incremental impact of each experiment. Like we have promoted people with 95% failure rate in experiments, because even though 95% of the cases they have failed, they have shown continuous improvement in their thought process and in the level of experiments that they were conducting. So that keeps the team motivated, and that's the status quo of life, especially in the data science world.
All right. Thanks, Srikanth. That's very insightful. One more question. Is the ML process having a lot of wastage? And so the techniques like lean may be required?
Uh, that's a nice point again. The problem here is, okay, let me tell you why it has wastage actually. I wouldn't call it because I think some of you are thinking it's wastage because 80-90% of experiments fail. But that's true in any scientific process. That's true in drug design, right? These failed experiments are not time wasted. They're lessons learned on what doesn't work, right? That's why this serious documentation. That's why documentation is so important. Again, we used to do this when somebody joins afresh, right? We used to ask them to read the weekly summary of all the experiments that all the scientists conducted in the last 6 months, because they know then what happens and what doesn't work. So we used to use all the failed experiments as a knowledge base internally. And again, I'm not an expert in the lean methodology that companies like, I know lean startups. I also know a little bit about the Toyota manufacturing process. But the problem is that's very engineering centric. That's not experimentation centric. Of course, lean startups are a little experimentation centric, but in so lean startups, some of the lessons may be transferable here. But this is again the best place that I learned a lot from drug design and scientific experiments, because everything fails there just like us. Again, as compared to drug design, or we are much better off, right? Because we at least have data and there is nothing else, so we can, it's like designing the first drug for, let's say, for any I won't say complex disease, but a simple disease, right? First let's say first paracetamol, right? Imagine you have all the data under the sun, all molecular structures. Designing the first medicine is not hard. Improving on top of it would become hard. That's what V2 V3 kicks in. So it's maybe some of the lessons from the lean startup world can be borrowed, but I haven't tried it.
All right. Okay. So again, this is a little lengthy question, Srikanth, with a little background. Customers are always demanding, due to this unpredictable nature of ML projects, challenging to meet immediate milestones, the probability of project failure is very high. Therefore, how do you define an ideal customer for ML project? What would be ideal customer behavior to enable the project success?
Again, a very reasonably good question, actually. I would say very good question, actually. It's a very reasonable question. And in a typical client management thing, I think if the client has nothing, let's say no machine learning system, nothing, then in the very first meeting, I see a lot of, in the client management part of IT services, etc., there is a lot of over promising that happens with respect to machine learning. And there's all this media which is saying, hey, Google did this, Amazon did this, and that creates a wrong sense of both perspective and possibility. So I think that's why there are also some of these roles which is called customer facing data scientists. I've started seeing some of these roles, or client facing data scientists. Their job is to sit in client interactions and set and agree on what will V1 be and be realistic about it. They're not saying, hey, this is, again, I think the right thing would be to set the expectation correct. Of course, the timelines, again, to be honest with you, if the customer has nothing, if your client has no machine learning system, they're just using some rule-based system, you can easily show value. That's the easy part. As long as you have data, you have processes, you have all of that. That's the easy part. The hard part will be, they will start. So I've seen some clients who say, hey, Google has this phenomenal chatbot. Can you build one for us? No, we can't. Google is sitting on like hundreds of petabytes of data with Google search. Do you have that? Google has a few thousand data scientists who are doing it. Do we have that? No. So I think setting that expectation with the client in the early meetings is appropriate, number one. But even in the client interactions, building V1 will be easy. Showing that quick impact, because you don't have to take state-of-the-art models. Take simple models as long as you have data. So in the very first client interactions, you should talk about data availability, how much of the commitment and time would their stakeholders from the company give you, right? So all these need to be discussed and the expectation has to be set right. I think because of the media bombardment, there is so much of wrong expectation set, which messes up things. It's unfortunate that some of the sales guys go and oversell, which can never be delivered. Forget about, like, even Even if you get the world's best scientists, with the data you have, with the systems you have, they can't deliver it. Come on, right? So that's a type of. So I think that setting the expectation right is important. Unfortunately, it's not being done in the right way. I've seen some companies do it brilliantly well, but I've seen a lot of overselling and under-delivering. So, I mean, at least my limited perspective. I've not worked so much in services, but I've had friends whom I discussed this with.
Okay. All right. Thanks, Srikanth. So this question is related to the basic ML knowledge that you quoted just a while ago. When you say PM needs to have a basic of ML, can you please explain what level are we expecting as basics, or some more explanation or to build some roadmap for the learning, especially if I don't have opportunity to work on real world projects?
So very nice. So I think there are few things that are a must. There are few which are optional. First, you have to learn the basic statistics, like what is mean, median, percentiles, quantiles, ratios, basic stuff. You have to learn basic hypothesis testing. Again, some of you have done your MBA. Probably you learned it in your MBA, if I'm not wrong, right? So this basic, applied statistics type of stuff. You don't have to know mathematical proofs and all the rigor, but you have to know, hey, in this situation, what type of hypothesis test might work, right? So this basic, again, the knowledge need not be mathematical. Even if it is applicative and intuitive, you're good. So basic statistics. As far as machine learning models themselves are concerned, you could have an intuitive understanding on what model works where, what model doesn't work well. A geometric intuition without going too deep into the math. Like I have a friend who works, who was a principal program manager at Microsoft. She just moved to Google as a director of engineering recently. So she didn't know the mathematical depth, but she knew what are all the top 30, 40 techniques that are actually used by scientists in her own org. She would go sit with them and ask them, hey, can you explain me as if I'm a 12th class student? Okay, I don't know anything beyond 12th class math. Can you explain me what it does? I mean, just diagrammatically. So if you can learn concepts from an intuition perspective, diagrammatic perspective, you don't have to dive too deep into the math. You just need to know, okay, these are the 10 things, these are the 10 stages in machine learning. For example, take data cleaning, right? What are the 4 or 5 things? If data is missing, what type of stuff do people do? Again, these are concepts that can be understood just with 10th class math, not even 11th, 12th math. These are very intuitive. You can explain most of this with diagrams. So if you can understand that, I think you're on the good path. So in terms of learning resources, to be honest with you, I don't know. Okay, there is one course that I can recommend, which is called, I think it's called AI for Everyone. It's on Coursera by Andrew Ng. You could look it up. The problem in that course is it is too basic, right? It's not at the PM level. There are also classical AI courses, even including the one that we offer or on Coursera, other universities. They go too deep into the math and the engineering aspects. So somewhere in between is what you need. But a good start could be the AI for Everyone Coursera course. That could be a good start. And then you can look up, okay, once you finish that, you get a basic foundation. Then you can say, hey, you know the list of techniques, right? You can just Google search for it. Let's say logistic regression. You can say, hey, can just Google for a blog, right? Or just go to images. Let me just quickly show you this. Quickly, in a minute, I'll show you this. I'll start sharing my screen. Okay, so I can just go to this and I can say, hey, logistic regression intuition. Sorry. You can just Google search for this and okay, forget about the theory. Okay, so you can just read. There are a lot of these blogs which just give you the intuitive feel of it. You can skip the math if you're not interested. You can skip some of the math, but you can just get an intuitive feel from a diagrammatic perspective. This could be one source, or you can just go to the Google image search. Okay, so when you do image search, okay, this is a video that I did a couple of years back, but yeah, here are some images. So you can get some basic geometric intuition. I think that's good enough to get started. And then you can keep going deeper and deeper by working with your machine learning teams as you need. Again, not every project would need the same thing, but you can just start with AI for Everyone at Coursera, read up simple blogs which give you the intuition or the geometry behind things, and that could be a good learning path.
All right, that's very good. Okay, you talked about building ML models. How about commercializing and other areas where it comes to launching it as a product? I think there's some disconnect in the question. How about commercialization other areas when it comes to launching it as a product?
So whether you're launching a product or building a service, right? It's the same thing. The journey is the same. So probably in your V1, when you build products, right? I'll give you an example. At our own startup, we have a product. We don't surface it externally. So we are sitting on literally a treasure trove of about 500,000 student questions that students have asked us over the last 4 years, 3.5 years. And we have answers that our team has given also. These are actual technical questions related to machine learning, software engineering, etc. So what we did was we said, okay, all this data, this is gold mine of data. We will just build some contextual search around it. And we will make this available internally and also for our students. It's a product. It's not a service, it's a product. But when we announced this product, very first version of it, we set the expectation right. We said, guys, this will fail X number of times in our own experiments. This is going to fail. It's not going to be perfect. It's going to be partially successful. It's going to be successful maybe 80-90% of the times. Whenever it doesn't work, here is a manual process. So if you're building a machine learning project, remember, even a project that, like for example, I'll give you a more concrete example. Imagine you're trying to build a system that diagnoses COVID using X-ray scans. Let's assume it's deployed at a large hospital chain. Now, the doctor gets the X-ray, digital X-ray. You build your model on top of it, you deploy it. It's a product. It's an actual product. The problem here is, even that machine learning system will fail. Even that machine learning system will be very less confident because it has never seen data like that. So in such a case, you clearly say, this happens more often in the earlier days of the product, right? So you clearly show to the doctor saying, hey, I'm not sure of this decision. I think the probability that this guy has COVID is only 51 or 52%, and I'm not at all confident about it. Please show it to an expert. So when you're building machine learning products, you need to have that case where human is in the loop. But in terms of technical challenges, it's no different from building services or building internal products or anything like that. It's the same.
Okay. When technical skills, what technical skills a PM should need to handle data science projects?
I think this was answered a while ago, right?
Yeah,
so you have to have an intuitive understanding. You need to understand what works, what doesn't work, what techniques can be applied where. You do not know the math. You just need to know the intuition and the applicative details. That's good enough.
Right. As we are in the PM track, don't have much AI ML knowledge. Where can we start become ML PM, and you can provide roadmap? I think that's answered with the Coursera course, right?
Yes.
Coursera course.
The Coursera's AI for everyone. That's a nice course. Again, that could be a starting point, and then you can do your homework research through multiple blogs.
Great.
That's the smoothest path that I know of.
Okay. How can I transition from a project manager role, managing three fixed price projects delivery, to a program manager? I think this is not relevant to this.
Yeah, I don't have expertise in this. Others might be better equipped to answer it.
Yeah. Arjun will take it offline with the PM folks. Okay, thank you, Srikanth. Great insights with relevant examples and few takeaways to use. My question is, what % of MNCs in the market are looking for a typical PM plus ML AI skills? For research, it is very low %. Your ideas, thoughts, please share your experience.
So that's a very nice question. So I think the requirement has started because I'm talking about even at large companies like Amazon, they have been looking for PMs in the last 6-7 years. The other companies, because there's a wide spectrum of companies there, they've started realizing that they need to hire specialized PMs for machine learning skills or for machine learning projects. That realization has kicked in much more recently. So while there are possibilities across the spectrum, right, from small startups, like even within our own startup, we are looking for a PM who knows some edtech, who knows some machine learning, all of the systems, right? So we don't find them. So what happens is we hire machine learning engineers and teach them the basics of program management or project management, and they traverse both these roles. So right now, in most companies, it is the classical program managers who are moving into those types of roles. But I see as more and more companies, teams, and clients ask and build more machine learning systems, the need might increase. Most likely, it will increase.
Yeah, it will keep now increasing. The demand is improving.
One more point here is the rise in demand for good data science PMs is proportional to the data scientists themselves. Because if you have 5 or 6 data scientists, right, you need a PM to manage all the stakeholders, everything. I think 1:5 is a reasonable approximation to that.
Right. So yeah, hi Srikanth, it's very good session. One general question: how a PM should carry forward a new ML data science project when it is kind of project is quite new and no data and market analysis available?
Oh, good. So my first recommendation there is please plan at least, if not immediately, please hire a data scientist who has actually built products or services. That is extremely important because a PM can comfortably work with the data scientist to say, hey, once you've committed to doing data science, the PM can collaborate with the data scientist and plan the way ahead. Because the problem here is if you don't have even a single data scientist or even a data analyst, creating that roadmap might become harder. Again, if you have somebody who is too much at an entry level, who has never built things, that can also be a problem. So, because what is feasible, what can you actually plan in the next 6 to 12 months, that can only come from somebody who has actually built products or services. So I would say your first priority could be hire a data science guy, either internally or externally, preferably somebody with a few years of experience and who has built things. I think the building things is important rather than experience, who has actually built and delivered stuff. So you can get them on board and then start digging into data because, like for example, if you don't know what data exists or what can be built, sometimes you don't have data internally, you have to get data externally. That will have its own timeline, right? So those challenges can, again, if the PM knows data science, great. He can do some of those estimations. But if he doesn't, then it's better to have somebody who has built data science products or services right next to you to plan together. That's what I would do. If, like, for example, if I were to do a program management thing, right? Like I would rather have somebody, a senior software manager or a senior PM or a principal PM who has done these things so that I can sit with him and say, hey, this is what I'm thinking. Can you correct me common mistakes? Can you just give your insights because I don't know this domain myself, right? So that's what I would do it myself.
Right. Thanks. Okay. So a couple of questions are on the related on the one part of how do we start with the AI course and details. Yeah. So for Coursera, AI for Everyone is the name of the course. So you can search for it and you can start going through it. And yeah, the next question we have is, in my experience at my organization, despite an early start, we continue to struggle with very poor quality of data. In fact, a few of my initial ML projects were only to demonstrate their potential value and create an awareness about importance of putting it in place ecosystem for good quality data. Is this the sort of journey that other organizations too must undertake?
Yes,
So
it's a must. Data quality is something that, to be honest with you, data scientists don't want to talk about it because it's a pain in the neck, right? Because they're like, dude, we have to go through all this journey now because they want to do the beautiful math, right? But if you have somebody who has been there, done that a little, they realize that without data quality, all the math is useless. It's like garbage in, garbage out. So I would foresee it already happened in some of the top product based companies. I'm sure it's just a matter of time before it comes down to other companies, which is data quality becomes the central, it will take the central stage. Just having high quality, labeled, cleaned data, I think I used to challenge some of my younger data scientists and mentees in the team saying that, guys, you take the most complex models in the world, you build a model. I will take the most basic logistic regression model or a decision tree model. I will clean my data better and I'll beat you guys. It was an open challenge that I used to make to all the younger scientists, just to teach them a lesson that data quality is as important as state-of-the-art machine learning. Then people realize that, yes, I can use machine learning techniques and data science techniques to even improve data quality. Like, for example, if I want to, I'll give you a simple example. Suppose I'm trying to collect some data in the medical domain, let's say x-rays. I'm just taking that as an example. Now you might say, hey, I have only one specialist doctor with me. Let's say only one pulmonologist with me who can look at these x-ray scans. And he can only say, yes, COVID, no COVID, right? Maybe only for, let's say, 100 times a day, because he will also get exhausted. He'll start making mistakes. So I can only label 100 data points. Now the question here to the data science guys is, which 100 data points do you want to get labeled by your pulmonologist? Can you be smart about it? Rather than just say, hey, here are 1,000 points, do it in 10 days. No. Can you be smart about reducing the costs of creating high quality data using data science techniques? And that's a great area of research in data science that is often underlooked. But people are realizing that, because a lot of data science projects fail because of data quality issues and just data availability issues. So people are realizing this, and even data scientists, slightly people who have been there for a while, like in my own team, we said, hey, here are 4 data scientists whose only job is to create better data. I don't care. You don't want that? Please leave the team. And we showed them that you guys can create much more business impact doing this than actually building some cutting edge deep learning model. And people, the moment they see the results, right, everybody buys into that. So as you rightly pointed out, you have to show that data point. You have to show that, okay, so a simple challenge that I tried with my team, you can do it. You can say, hey, this is the raw data. This is my cleaned data. Raw data, you use your state-of-the-art deep learning models. I'll use simple models. I'll beat you guys. Simple challenge. And that sends a very, very strong message across the org. That's what worked for me.
Yeah. Thanks. How does typical program managers with IT service experience transition to data science and ML program management roles? Yeah, I think this has been answered by having ML knowledge and the initial knowledge related to the machine learning.
One more point, if I may add, Praveen, there is,
yeah, please. Yeah.
As a program manager, you have a lot of control on the paths that the program takes, right? Since you're learning you also want to implement what you've learned, right? So you already learned, let's say, basic machine learning, the intuition behind machine learning algorithms. Hire a machine learning guy or a data science guy, number one, if you can, if you have the authority and power and resources to do it, number one. Number two, try to add a machine learning module or component into your bigger IT services problem. Give it free to your initial customers. Imagine if your customer is a bank or something like that, right? Build them a simple machine learning system and give it free. This is also part of your customer engagement and things like that, client engagement and things. Take initiative to realize what can be built, how to actually add value to your client or customer. Build a simple POC and show the value. That's real world experience for you there.
Yeah. Okay. Right. I joined late. Is the recording? Yeah, the recording will be available in the PMIPCC YouTube channel. You can watch there. In a couple of days, we'll upload there. Good session, Srikanth. What's your suggestion if any PMI project manager wants to move to AI/ML? What role can be targeted?
I think that the most logical path will be a PM for data science and machine learning projects. That's the cleanest path, or that's the most immediate path, because you already have built core skills in program management. And trust me, there is a huge scarcity of good PMs who can manage data science problems. I know teams that I've worked earlier with, they're struggling to hire good PMs. And the good PMs who have managed, like one of my friends that I was talking to about, she was a principal program manager of machine learning products at Microsoft, and she learned so much that she's now a director of engineering at Google. So there's a very neat growth path for you even in that. You can easily go fairly senior because you are a stakeholder and you are a manager of stakeholders, and you have so much on where the project or product will head. So you can actually show real impact that way.
Right. Great. Okay. Hello, Srikanth. What is the most effective tool for ML or data science? I'm a mechanical engineer with knowledge on MATLAB, Mata LB. I don't know is this MATLAB or MATLAB.
I guess
So I
MATLAB.
understand. Yeah, I still understand a little bit of regression analysis. So
So,
looking for an effective tool. Yeah.
so unfortunately, there is no one tool. Like I understand that for mechanical engineers and for some physicists, etc., MATLAB is a very nice, cool tool. But MATLAB is not so widely used in the machine learning world because of its proprietary nature. We prefer open source, publicly available, easy to modify tools. There are some tools, for example, for all of deep learning, people use TensorFlow from Google, open source, very, very good, or they use PyTorch from Facebook. So these are the two popular tools for deep learning. For machine learning itself, there are so many tools. There is scikit-learn. Again, all this, Python is the most popular language in data science. Some people also do it in a statistical language like R. But within Python ecosystem, you have scikit-learn, you have XGBoost. Of course, you have Spark. When you have large data, you have the Spark ML, which is basically a part of the larger distributed system framework called Spark, or a big data system called Spark. And there is no one tool. Oftentimes, these tools will not suffice what we have to do, right? So we end up using any open source tool as long as it comes from a genuine source, as long as it is documented well, as long as it's implementing cutting edge research. For example, to give you a context, right? So we were recently using a research paper from Google, which they published last year on a very state-of-the-art algorithm, very, very fast. It is reducing our cost significantly. So what do? Implementing that whole thing will take maybe a month or two for some of our engineers. Google, through their research, they do open source publication. We took the open source publication, read through the code, understood, modified it, changed it to our needs, and used it. Simple. This is a more status quo, or the normal way of doing in data science. Again, it differs from the mechanical engineering or production engineering type of frameworks where people mostly use MATLAB.
Okay, great. Thanks. Okay, how good session. How were PhDs from computational fluid dynamics were helpful in AI, ML domains, or as a PM roles?
Very nice. So two parts to that. So first, let's talk about the data science itself. Then I'll come to the PM part. So the computational fluid dynamics PhDs, right? They're brilliant in mathematics. They have lot of mathematical strength, and they know computational tools, right? Many of them actually implemented modifications of CFD algorithms in C or C++, some in MATLAB also. So in machine learning, the idea, at least a few years back, even now to a large extent, is if you have a PhD in a quantitative field, in a scientific field, and if you know the math, you can pick up machine learning in just 2 to 3 months. And people who came with PhDs in CFDs, they had phenomenal math. Like we even hired people who came from statistics PhDs, or people who came with PhDs in quantum mechanics, statistical mechanics, all these, like physics PhDs, right? And those guys know so much math. Like I used to sit with one of my teammates who is a PhD postdoc in stats, and he taught me so much statistics more than what I ever learned in machine learning. So that's one. So they have the skills. It's just about just learning the base. For them, learning machine learning will take 3 months. They can read up a couple of books, work with the team, and they will learn everything. They're brilliant because their math is strong, number one. From a program management point, some of these people also used to do program management because they were also interested in it, partly because they came from large research labs. They were either PhDs or postdocs, and they were managing the scientific work done in that lab. And these labs were like funded by NSF, all the large government fund. These are in universities. So they would have a university with a professor, few postdocs, few PhDs, and they had like tens of millions of dollars, or at least a few $1 million of funding, and they were designing these systems and engines and models from scratch. So they had that scientific program management mindset because they knew that 90% of their experiments would fail. So they were also, so a lot of lessons I borrowed from their experiences in university research labs or government research labs. And some of the things that we implemented actually came from them, not from me. So yeah, that's how they contributed both to the program management and process improvements, as well as the core data science pieces.
All right, great. So with mathematics still be needed as a cloud vendor or releasing a lot of AI services to allow software engineers to build AI-based applications.
Very nice. So the problem with, I would prefer using any cloud service any day. But the problem is, okay, let me give you an analogy. Okay, so let me give you a nice analogy, a proxy analogy, if I may say so. Just because you can get a database right now on AWS using RDS or in Azure, does it mean that the database admin role died? Or do students not have to learn about databases anymore? Do students don't have to learn about distributed systems anymore? To be a good software engineer, like for example, I'll give you an example, right? Because we used to hire a lot of software engineers, even senior principal engineers. What top companies look for is not how much you know in AWS. They ask you, okay, so you've used, let's say, a load balancer, right? They say, how does a load balancer work internally? This is my 1 hour discussion. My discussion, 1 hour interview for a principal engineer or a senior engineer is, okay, you've used, let's say, Elasticsearch or some EC2 or S3. How do we design S3 from scratch? Let's do it together. Let's sit on a whiteboard. Let's assume we are 2-member team. We have to design S3 in the next 6 months. How do we design that? Because people who know the internals on how things work, they are the ones who will be able to leverage them the best. Like I have used, like all of our startup runs on AWS, right? We have been able to speed up because of cloud services. But if I do not know how Elasticsearch works or how RDS works or how load balancing works or how cloud-based AI systems work, my actual impact will be less and the number of mistakes I will commit will be more. So understanding the internals of these cloud-based systems is super duper important. If you don't know it, you'll make some progress, but there will be more mistakes that you will commit. Number one. Number two is if you don't know what's happening internally, it's a black box, which means somewhere or other you'll mess it up. Like for example, this is true even for Java developers, right? The best Java developers that I have interviewed can tell me how a JVM works. Because those guys can now go ahead and build extremely large scale, extremely low latency systems because they know the nitty-gritty details of how JVM works. Others might be able to write Java code just using that, but they will not be the best of the best. And that's what will help you survive in the long run, right? Otherwise, what's the difference between a 5 years Java engineer and 10 years Java engineer? Right? Just to give you that example.
Oh, great analogy, Srikanth. That's wonderful. Yeah, it can be related to any of your learnings, right? Everything. Yeah. Okay. So I don't know the name from the question is from Hi. Srikanth, thanks for a fantastic, insightful session. And he has 3 questions. Any emerging framework or methodology being used for AI and ML projects? That's his first question.
So the PMI document that I just showed you, right? It's called, I forgot what's the title of
Playbook.
it. It's called the Playbook. I really loved it. Actually, Praveen and Suma actually shared this with me a few days back. I really enjoyed reading through it. I only wish I had this handy a decade earlier. But it's phenomenal. I loved it. I mean, there is so much. Probably you'll see a lot of overlap because I wrote these notes. I thought I would read it after I write the notes because otherwise I would get impacted by it, right? So I started writing all the notes and the slides and I saw 70-80% overlap between both of them. And I'm happy that somebody wrote it. I mean, this is so damn useful for actual practitioners. So if you're planning or if you're leading data science problems, this PMI doc, this playbook is a must read. Actually, I sent it to all the PMs that I knew earlier in my career, saying, even to my teams, saying, guys, this talks about a lot of what you guys are doing, but there are new lessons that you can learn from this. I'm sure some of them may already know it, but.
Yeah, so for the guys who don't know, the link has been shared in the chat window. You can just download from there, the playbook. Okay. Yeah. Since second question, since the ML models are iterative by nature, where confidence improves with more data, uncovering more variables, etc. When do you want when do we know we have arrived? Would be a great to hear thoughts on this.
So my suggestion is, again, I come from the internet company's perspective. I would say, as long as you have minimum value that you're creating, let's assume So I'll give you an actual dollar amount impact, right? If you say, hey, we can create $1 million more, you just talk to your director or VP and say, hey guys, is $1 million okay for you for version 0.1? Most likely they'll say yes. Nobody wants to leave $1 million on the table. Go push it out and iterate. Push fast, iterate fast. I think that's the mentality that will help you. That works brilliantly well. So push fast, experiment fast, learn as fast as possible. Sometimes the impact may not be as big, but that's okay. That is lesson learned. So don't wait to make $100 million impact, because that eventually will happen. Like, there is a very interesting statistic, publicly available statistic, that almost 1/3 of sales on Amazon happen because of recommender systems. I'm sure that was not the case a decade ago, right? Right now, a lot of sales happen because of search ads. That was not the case when we started showing these a few years back. So there is always day zero to things. As long as you have the minimum business impact agreed with your stakeholders, push it, iterate, iterate, iterate. Again, this is coming from my internet company perspective. This may not always be possible, especially in healthcare where there are regulatory processes. So there again, you want, because if you get an FDA approval for some machine learning stuff that you have built, right, and you want to productionize it, you need to wait again a year. So you want to say, hey, I want to go with my best shot in the first go, right? So go as long as you're creating a unique value to your consumers. Like, will a consumer buy yours versus the others with the KPIs and the improvements that you've measured? Is the lift that you're providing, either in price, performance, whatever it is, right? Is it better? Is it reasonably better that a customer will buy you and not the others? Okay, that's it.
Yeah. Can you share some more light on change management in AI/ML projects once they are operationalized? How do we set up the response plans?
Okay, that's what is the monitoring part that I was talking to you about. So typically the monitoring part works like this. So you have a model that is running in production, and on regular intervals, it could be hourly, daily, weekly, whatever it is, you keep collecting the model's performance on the real data. For example, suppose you have deployed a X-ray computer vision solution to doctors. Suppose the doctor sees the X-ray, the computer vision system or the machine learning deep learning system actually tells them that this person has so and so, diagnoses something and gives a reasoning. The doctor can agree to it or disagree to it, right? You take that feedback. Similarly, in the case of recommender systems, right? Has the customer bought it? Whatever you're recommending, are customers buying it, right? Or if you're showing ads, are customers clicking on those ads and buying those things? It is this feedback loop that you measure. And as long as that, as the rate of, or at least whatever, you can create a metric there, right? And as long as that metric is sensible, you can continue doing as is. But oftentimes they will go back and forth, right? There could be seasonality. There could be, like, for example, the Delta variant of COVID might have a different impact on lung scans. Tomorrow, Lambda might have a different impact, right? Similarly, this could be a completely different season because everybody is ordering from home now, right? So there will all be those crazy things. What we typically do is, whenever something crazy happens, we have data analysts sitting on it and debugging what exactly happened. Again, we had actually in our own team, we had dedicated data scientists whose job is to monitor and constantly do data analysis on why the model is behaving like this at this point. If at any point they raise a trigger, we go back to the drawing board. It's like a P1 issue for us. If the model is not behaving, it's a P1 issue. Of course, there are mechanisms where you say, hey, let's retrain the model on more recent data, push it out. That mechanism already exists. But if there is something which is a major issue, it's a P1 issue. We had only one instance with the P0, unfortunately, because some ad was shown from Amazon on a piracy website. So there was some of those P0 issues, but typically it's P1 issues, and you can get over them, right? So that's the change management, or that's the monitoring part of it, which is also super duper important. I did not have time to go in depth into it.
All right. So yeah, the next question is, what would be a good number of data sets for V1 training the model?
So it's not like the number of data sets. It all depends on, for example, again, you can build machine learning models with a few thousand points to a few billion points. right? So it's not just about the number of data sets, but the simple question you have to ask yourself is whatever data I have, whatever variables or features I have, is it sufficient to create basic value, basic incremental value that all my stakeholders are, okay, let's do it. Again, in V1, you're not trying to say, hey, this is my best product. No, that's not your goal. You're just, suppose if you're making, let's say $10 million now, your goal is, okay, I will just, suppose your rule-based system that some of your engineers have written makes $10 million, right? You just say, hey, can I make $12 million in the next 1 month? It's a trade-off between speed and oftentimes about the basic stuff that you can get done. Whatever data you need for that, get it done. Incrementally, when you have to improve it, then you can look for more data sources. Again, it's not a number, it's a richness of data very often.
Yes.
It's never just the number of data sets, because all of it could lie in one data set and that's God sent, right? Sometimes. So yeah, it's a richness, I would say, and how much incremental value it can add.
Right.
I'll give you a concrete example if I may.
Yeah, please.
So this is not at Amazon, but at a different, like a FANG company. So in one of their ads, so I study ads because I worked on internet ads for a very long time. So they were trying to show which ads to show to which customer on their multi-billion people platform. Now, one of the engineers said, it's not a machine learning guy, one of the engineers said, are there people who are clickers, who click on ads? Simple question, are there clickers and non-clickers? He's not a machine learning guy. He asked a very simple question. They did the analysis and they realized that if you target clickers more, these are people who tend to click on ads for whatever reason. Maybe they're retired people living in Florida who are like, "Theek hai yaar, let me see what this cool thing is all about," right? You don't know who they are. But there are clickers and non-clickers. By just prioritizing more relevant ads for clickers alone. So they completely build a different model for clickers, different model for non-clickers. Their revenue literally shot up by 12% overnight. And this data was sitting all around. It was sitting in their databases. Nobody just bothered to ask the right question. So oftentimes data science work in terms of data is more like a Sherlock Holmes work.
Oh, great. Yeah, with the large companies coming up with the low code platforms to build ML models, what do you think will be a future for DS and ML, and how will the impact of PM working in this domain?
So it will be exactly the impact that cloud systems had on software development. First thing it does is, like even a small startup, right? Even a small startup like ours can, like we have our own streaming platform built from scratch, like completely encrypted streaming platform the way Netflix has. And why are we able to do it? Because many of the tools required for it are available on AWS. And what Netflix uses, the same thing we use. So what it's done is it's democratized access, number one. Number two is if such a tool did not exist, it would take us years to build it from scratch, literally years to build it. It's not that it's a crazy hard problem. There are some engineering challenges. While you might have the engineering skill set to build it, it just takes time. So first thing it does is it gives access to great tools, number one, so that even small startups, like I think many of you know this, right? WhatsApp in its early days just had 15 people, 15 engineers. That's it. And they're serving a few billion people with just 15 engineers. That is unheard of just a decade ago because they're just simply doing everything. They were doing everything on AWS then. So I think cloud is a even playing field, whether you're a large startup, services company, anybody, number one. But it doesn't, it speeds up things. It speeds up things. It also makes a few black boxes. But here is a big cautionary thing. If you don't understand how the tool works internally, very likely you will not use it to its full potential, or you will misuse it. That is the biggest problem I see. Because I've been in teams at large FANG companies like Amazon, where we said, okay, here is Amazon SageMaker, right? Amazon SageMaker was just getting built at that time. We said, we gave it to a bunch of very nice, very good engineers. We said, guys, go figure it out. And the very first diagnosis of this is, okay, Okay, they try to put together something. They did not understand how things work internally. You just add one data scientist to that, everything changes overnight. So with cloud-based tools, low-code tools, things will speed up. It's a leveling field for everyone, but you have to understand how the SageMaker works internally. You have to understand how TensorFlow works internally. Because if you don't, you're either misutilizing it or underutilizing it.
Oh, great. This question is related to PMI Hyderabad chapter. So whoever wanted to join with the Hyderabad chapter, they can write a mail to membership@pmipcc.org. So we'll help you out there. Okay. And the next question is, okay.
Hey, somebody said, what is P0? I'm sorry. Sorry.
Go ahead.
Somebody said, what is P0, P1? It's just the severity of issues. I'm sorry. I thought it's a general term. I'm sorry. So P0 means the highest severity, where you get a mail from Jeff at Amazon. We used to get a mail from Jeff at Amazon.com with a question mark, which means, guys, something is really, really wrong. Sit down, fix it. P0 is the highest severity. P0 is the next, and so on and so forth.
Right. Okay. I'm working as a software product development for 17 years. I don't have AI projects in current employer. If I wanted to switch AI ML company as a project manager after having some basic knowledge by going through courses, will I still be relevant and wanted in the market for those kind of projects? Is there a way to be more understanding through practical oriented so that the relevance can be improved?
Yes. So we see a lot of people, again, not as a PMs, but we see a lot of people with 10 to 15 years experience, typically in that range, who leverage their engineering skill set and transition to roles in data science, not necessarily PM. What they typically do is as follows. This is a standard playbook that we have seen, which is first in their teams, suppose you're learning, let's say, machine learning data science. First thing is they try to apply whatever they're learning and build a small module in their broader product to showcase to their client or their team that, yes, there is this value. Doing it within the context of your larger project, because you already have a lot of experience, right? You know how your whole product or project or system works. Try to add some module or modules to improve the overall system. That's the first step. That's how you actually, because this is something that you can do fast and build on top of it. So you start with a small module first, then build a slightly few modules and build a small product around it or a small incremental service around it. Once you build all that, you can easily transition into a machine learning engineer type of role or software engineer with machine learning, because you already can do 90% of what a data scientist does in terms of the engineering components of it. You just had to learn this additional stuff. So we haven't seen, to be honest, again, within our own student pool of about 40,000 students across the world, at Applied AI Coach and Applied Roots, we have seen people with your experience moving more to machine learning engineering roles, not so much PMs. Again, we have very few PMs in our student pool, and in my own experience, like if I'm talking about Applied AI Coach, we have some PMs from FANG-like companies who are learning it because they want to go into the details because they're managing machine learning products. But I don't recommend it because we go too deep into the math and the engineering, which may not be optimal for everyone.
Okay. Python or Pig, easy to implement. Which one is easy to implement?
Okay.
I think it's a question. Python, R, and Pig.
So Pig is basically a programming and SQL-like programming environment for Hadoop. You can also do it in Spark now. So you can think of Pig as something that you'll use instead of SQL, right? Not as like you can use Pig as a replacement to SQL if you choose to. More and more, again, people do use Pig scripts or they use SQL. It's a choice between both of them. I like Pig personally because I was fortunate to be one of the early users of Pig at Yahoo Research where it was actually built. It's called the Pig Latin. But yeah, you can use both of them. Now coming to R and Python, I would pick Python any day. The reason being the availability of a larger pool of software and tools, right? R is great for statistical analysis, but modern machine learning has moved away a lot from classical statistical analysis. So R is great if you're doing core stats, but most of what you can do in R, you can do in Python also. Today, a vast majority of machine learning projects that are getting started are done in Python. There are some older projects, right? Old, like example, a lot of banks, right? They have statisticians working on fraud detection, etc. Some of that code is written in R. So the newer data scientists are also coding in R because they have to build on top of what already exists. But all the more modern stuff is all Python based. I think that's hard to beat now. It's become, because there are literally thousands of brilliant libraries to do that. It's hard to beat that competitive advantage that Python has.
Okay. I think we are good with the questions. Some of the questions that I see are repetitive, related to the learning, initial steps. How do we transition? Those are the questions that are coming up.
I think there are 2 questions in Q&A, right?
Okay, let me check it out. I'm looking at the Q&A.
Yes, there are quite a few questions there as well.
Yeah, let me open it up, Suma. Thank you. Okay, customers are always demanding due to this unpredictable nature of I think this is the question that we
answered that. Probably it's a ping privately to me. But guys, I'm not seeing my Q&A, but I have 2 questions here. I'll try to answer them.
Please go ahead.
So what type of modeling is used in machine learning? How different is it from data modeling? Again, data modeling is a very broad term. It could mean many things, from modeling a database storage system to, so machine learning modeling is basically how do you use concepts in optimization, or how do you use concepts in statistics or mathematics and computer science to actually build machine learning models like logistic regression, random forests, convolutional neural networks, etc. So data modeling, again, there are many types of data modeling. One type of data modeling that's used in IT typically is how do you store your data, right? Or how do you distribute your data across multiple data stores? That's not what ML does. ML does more like, okay, I have all these patients' data. Given a new patient, can I predict this patient has a medical condition or not, right? So it's more statistical, more mathematical. Of course, it's in the intersection of statistics, mathematical optimization, applied mathematics, computer science, etc.
Okay. So there's one question here. Is Six Sigma and ML are interrelated?
I don't know much about Six. I know what it means, but I don't know how they're related. I mean, I don't have a lot of expertise in it to comment on it. I know that Six Sigma processes which are there in manufacturing and other places. I don't know how it's connected to machine learning, at least from my vantage point.
I think yes. So yeah, that's the only question that I see as a new question from the chat window. So people might have typed the questions here and there because I was reading through chat.
Cool. No problem.
Yeah. All right. We are actually on top of the hour. Suma, over to you.
Thank you, Praveen. Firstly, let me thank Srikanth for a fantabulous session. In fact, it's like a 101 on data science, machine learning, and AI. So a lot of queries that I had while managing my first data science project, I guess you have answered here, and it's making me more and more thirsty for knowledge. It's always there. And meanwhile, I see that many of the folks, they want to transition or look at options to transition to, if they're looking at future projects or whatever it is, into data science projects, what is the delta that they have to look at and all that. So since we do not have the time now, I would request them to please fill that in the feedback form in the section message to speaker. All that will be collated, sent to Srikanth directly, and we will be showcasing this again back to you. Srikanth, hope that is fine. We are taking the liberty of not asking you.
Please, no problem. Please collate all the FAQs that folks have, the participants have, share them with me. I'll quickly record audio replies because that's the fastest way for me, and share the responses back to you.
Perfect. Thank you so much.
Yeah.
Lata is sharing the same in the chat box right now, the feedback form. Thank you for all the guests from the non-PMI who joined us. In fact, you have enriched our session as well. In place of PMI ID, please fill in 000. And yet, please fill in your feedback in detail so that we can have the, details so that we can make our sessions better. One
Yeah.
more thing, Praveen, before handing over to you, the all important question for the PMI guys here, the PDU code. Lata, if you would please type in the PDU code. We have 1.5 PDUs for this session, and it is shared in the chat box. Okay. So thank you so much for that, Lata. Praveen,
So,
over to you.
Praveen, if I may take the liberty, I've just shared
Please.
this handwritten slides to you on WhatsApp. Please feel free to
Please.
share it with all the participants.
Great, great. Yes, yes. We'd like to upload it in our drive and share it
Please,
with the people.
please.
Okay. Thank you so much for that. Suma?
Srikanth, if I may, Praveen, let me comment on your beautiful handwriting. In fact, I can never annotate on a screen or whatever it is. My square turns into a circle or whatever it is. But really beautiful way of, the session. I've seen PPTs, but using a blackboard on a screen, that's awesome. Thank you.
Yeah, so I think in the edtech space, we are used to this. So yeah.
Yeah, great, great. All right. So I think that's we are at the end of the session. I would like to thank you all attendees, our guest speaker, presenter Srikanth Varma, for a wonderful, insightful session that you had, and all the volunteers, Seshu, Devasena, Harita, Avipriya, and communication team to reach the people and get the registrations and make this particular session more interactive and interesting. And my core board member Suma and other members who supported me, and helped me to arrange this session. And but yeah, I think me and Srikanth were discussing with one of the common friend from last 1.5 months to have this session. Great that we had this session and lot of insights, and it got benefited. And the first and foremost feedback is from Suma, that she was able to correlate many things. Yeah. Thank you so much, everyone, and making this event so successful. And have a great day. Thank you so much.
Thank you, everyone. Thank you from my side also. Thank you very much for organizing it. And also thanks to all the participants for a great Q&A. Thank you.
Thank you.
Thank you, Srikanth. Thank you,
Yeah,
Praveen.
this session will be available through PMIPCC YouTube channel for a couple of days.
Good job, guys. Thank you so much.
Thanks a lot.
Thank you.
Thank you.
Thanks, everyone.
Thank you, Srikanth.
Thank you and have a happy
Thank
weekend,
you.
everyone. Take care.
Take care.
Praveen, I think we are good to stop the session, or
Yes, yes. I am doing it. Yes.
thank you. Bye.
Bye.